Okay, so looking at the area of a composite figure here. So let's just look at the diagram we're given to start. Looks like we have... Now, there's a couple different ways you could divide this up. I ended up dropping down a height, noticing that we didn't have a height, and I see a way to get that. Now, I don't want to get too far ahead of myself. But anyways, if I'm going by that, I could look at the shape like it's a triangle, a rectangle, and then, half of a circle, so a semicircle there. Now, the way that I ultimately do end up looking at this shape here, and you can do it the way I just said, but I'm looking at basically from here to the left as a trapezoid, save a little time, and then we have a semicircle to the right, half of a circle. So when we go into the equation for the area of the semicircle, keep in mind, it's just half of a circle. So we'll do the equation for the area of a circle and then just divide it by 2. All right, so let's look at what we need. So if we're doing the area of the trapezoid, we have base 1 is 22, we have base 2 is 31 centimeters. We don't have the height. Now, we do have the information to get the height. Now, that's why I dropped down this perpendicular height at the beginning. I recognize right away, okay, I have a way to get this length here, and then I have a nice little hypotenuse to use, and we can, work the Pythagorean theorem like we've had to do multiple times this chapter. Anyways, so if this distance across is 22 and it stops here, this whole distance across is 31. It keeps going through that point. All we have to do is 31 minus the 22 that would be right here, and we find out that there's 9 left for this little length here on the bottom left. So we have a right triangle where we have our height and 9 for the legs, and we have 15 for the hypotenuse. So we're going to use the Pythagorean theorem. We have h squared plus 9 squared equals 15 squared. Square the 9, you're going to get 81. Square the 15, you're going to get 225. We subtract 81 from both sides, and we get h squared equals 144. We're going to take the square root of both sides and end up getting h equals 12. So we have our height. That's, big news. We're going to be able to go after the area of the trapezoid now. All right, so also big news here. Notice that the diameter of that semicircle is basically a height. It's perpendicular to each side of the trapezoid. So that 12 that we got is actually going to apply right here as well. And then when we need to change that into a radius, we'll be able to do that. All right, so I did a little diagram here, and tell you what, let's just get right on with the radius. If we know the diameter is 12, we divide that by 2, we have a radius of 6. So that's going to come in handy in a minute. Now, what I did with my answer key, just to show you guys, the whole composite figure equals the area of the trapezoid on the left plus the semicircle on the right. I wanted to kind of draw a visual that you guys could see there. So again, total area is the area of a trapezoid plus the area of a semicircle in this case. So first, I ended up doing the area of the trapezoid. You want to take your time, separate the two areas, and make sure you get them both right, and then you can go back to that equation we just made. So a trapezoid is base 1 plus base 2 times the height divided by 2. Now, we already had the base and the height. The base 1 and base 2. We have 22 and 31 that we're going to be adding together there. We worked hard with the Pythagorean theorem to get our height of 12, and then we're going to be dividing that by 2. So 22 plus 31 gives us 53. We have 53 times our height of 12 is going to give us 636, and then we're dividing that by 2 to finish it off. So that's going to be 318 centimeters squared. Now, looking at the area of a semicircle, I added a little note there. We have the divided by 2 included because it's half of a circle. So we have area equals pi r squared, the equation for the area of a circle, and then we're just dividing it by 2. So we found out above that the radius is 6 when we cut 12 in half, so that we're going to be plugging in pi times 6 squared. So we square 6, we're going to get 36. We end up with 36 pi divided by 2. And to finish it off, just going to divide right there. We got 18 pi centimeters squared. Now, I didn't even bother getting a decimal yet because, again, I don't like rounding until I really need to because I don't want to, throw off the integrity of the answer. I don't want to compromise that answer. So back to the equation we made where the total area equals the area of the trapezoid plus the area of the semicircle. We're going to be adding 318 for the trapezoid plus 18 pi for the semicircle. When we add those two together on our calculators and round to the nearest tenth, you should get 374.5 centimeters squared. So just breaking it down into more manageable shapes, adding them together.